Hi, and welcome to our third video on how to model multifamily buildings in Energy Pro. In the last video, we discussed how to model the plants or the water components of the building, whether it be for heating, cooling, or domestic hot water. In this video, we will be going over the HVAC systems, or the heating, ventilation, and air conditioning systems in Energy Pro. So we'll be working in this icon here called the systems. Once you click on this systems, you'll see this section populate with tabs, and each tab will need inputs related to the HVAC components. So in the first video, we basically were given to us information about our building, and our building analyst told us that we had three HVAC systems. One PTAC, or package terminal air conditioner unit, that serves the common area, a package unit that serves just the top floor, and we have individual space wall heaters that serve the middle components, or the middle level assemblies. So looking at the HVAC icon, you will see 5 tabs, and we're going to go ahead and start off with our general icon here, or general tab here. As you can see, I named the system accordingly. It's a package terminal air conditioner. The system is existing. We have 2 of these package terminal air conditioners that serve our common areas, so we'll use our multiplier to denote that. So once we have that set up, we can click our system and set that up accordingly. So what I went in and did was I renamed one of these systems and gave it the information from the analyst, or the ASHRAE level 2 assessment. So we'll name that as our general package terminal air conditioner. It's pretty easy to rename. You will change the system type based on the setup. This is going to be electric resistance, and we're going to say this is a 5.5 HSPF, and get information about the cooling side as well. Okay, again, this information should be found from the analyst. If not, then use the Energy Pro defaults. So we're going to be working in the heating tab, the cooling tab, put information about the output and the efficiency. And next, we're going to jump to the fans icon and put in information about the fans. This should be these package terminal air conditioners should have a relatively low airflow and fan watt or horsepower capacity, so make sure you don't put in a huge number. Something like so. And you can ignore the evaporative and the cooling and the curves tab. Okay, so once we have that information in the general section inputted, we can go to our distribution. Again, it's existing. We don't have any ducts. It's no fan. And we have, again, cooling ductless. And this fan really relates to an air handler. But since we have a fan with our package terminal air conditioner, we're going to change that. Relatively small fan. This residential tab will put in information on our thermostat. Since there's no programmable thermostat, we're going to leave that as no setback. But if we did, we're going to set that as setback. We're going to ignore the living and the sleeping drop down icons. The hydronic space heating, this drop down is only if we have a boiler that is providing us with hot water or steam for our system. So if it's a boiler that's providing hot water, we will say that it's a heating boiler that's providing the heat. And if it's a hot water tank, like an indirect storage tank from a solar tank, then we would say, or even if it's just a water heater that's providing the hot water in an open loop system, we would say that domestic hot water is providing the heat. And that's related to our plan icon. So if we have a heating hot water system modeled, it would be pulling this information if we selected the heating hot water, and it would be pulling this information if we selected domestic hot water provides the heat. So that's in our residential section here. We'll put in information if we have a mechanical ventilation system. Since this is a package terminal air conditioner and doesn't do any mechanical ventilation, we can leave that alone. The HERS tab will put in information about our cooling verification. Since we're at a package terminal air conditioning unit, there isn't really any cooling verification we can do. And any information on the building's infiltration. And since we aren't going to do any blower door testing, we can ignore this section altogether, and we can also ignore the MEC too. So moving on to our package unit that's supplying our top level. Again, we're going to see we're going to need to go to the general icon, change the name accordingly, set the system type as existing, and we're going to go into our existing system and build out our system based on the heating components. As you can see, I have a package unit, gas furnace, it's central, 100,000 BTU, and it's a 78% efficient system. And I modeled in the cooling component side. It's a 5-ton. It's the lowest efficient I could find, or based on this. Again, I should stress this should be information given to you from the analyst, and information about the fan, the airflow, and the power, the horse pump power. And our distribution tab, since we have a package system, it is ducted, so we're going to say it's existing. We're going to say that the existing system is ducted. The ducts are located outdoor with no insulation. And if you did not test the duct system, you can use the duct leakage not verified. And if you did test it, you can go ahead and use the low leakage AHU or HERS2 leakage verified, and you put in that percentage. And for this example, we're going to say that these top units have programmable thermostats, and it does do ventilation. It does have a fan mode and a relatively high watt draw per CFM. It's best that the refrigerant charge in the ear is verified from the analyst, but if not, then leave that blank or unchecked, and no blower door testing. Moving on to our individual space heaters. Again, the general icon. We're going to name our convention accordingly. Click our system and set up our wall heaters as package units. They're all gas furnace. Should not be central. Should be all room. Relatively low BTU output on these guys, and a really low efficiency. And since I don't have any cooling on these guys or these units, I'm going to zero these out, and that gives me a non-applicable for my efficiency, so I can just go ahead and leave that as 1, since it won't play into the calculations here. Going into our distribution tab, I'm going to say that the heating distribution is ductless with no fan, since it's a wall heater. I don't have any cooling, so I can say this is ductless. And all the other icons will gray out. I don't have a thermostat, programmable thermostat, and I don't have any mechanical ventilation for these units. No blower door testing as well. And again, if I had a hydronic system that served these units, I would set these wall units to radiators. I would set this up as something like a 4-pipe fan coil or a split system. Let's use a split system for now. And I would set that efficiency based on my heating hot water boiler, or I can set it to gas or hot water, and Energy Pro will know to pull that from whatever I set my thermostat to here. Let's say it's my domestic hot water boiler. Then this knows by default that my heating hot water is from my boiler. But if I did not set up that residential tab accordingly, I would leave that as a gas furnace and say that my radiator has the same efficiency as my boiler or my heating hot water system. So let's go ahead and say that that's a heating hot water, and I don't have, again, any cooling. But if I did have a fan coil that did do cooling, I could say it's a 4-pipe fan coil, and Energy Pro knows that my water heating system, based on my domestic hot water boiler, will be providing the system. Okay, that pretty much wraps up the system level components in Energy Pro. So again, if you have any system level questions, you can always email Build It Green, or you can build your own system given the system type and the system components. It's always a good idea to have a friend or an associate who is a mechanical engineer or a plumber. These people can always give you assistance when specifying components or what the system level components are needed in order to model. Thank you again for watching, and hope to see you in the next video.